Okay, welcome team. Session 6 of the session 6 of GenAI training RAG architecture. So as I was talking about, I encourage everyone to check out the recordings, download the notebooks, create API keys, and start running, executing with different use cases and ask different questions, use different vector databases, different algorithms for search and build semantic search, right? And this is all it takes to build a chatbot, basically. Okay. You have your own database, and then you have this, except that, okay, you don't have a web page where you can type the question. But this is all the basic of the underlying engine of any chatbot, customer support chatbot, if you think of. So bring in your own data, bring in your use cases like any of the customer support or support manuals, kind of a thing, or customer support issues. Try putting that data into vector database, and then um, creating a chatbot to ask questions, to talk to it with different chunk sizes, with different overlaps and all of that. Okay. So as I was mentioning today, we'll reiterate this and then wrap this up, the RAG architecture, at least from the code perspective. So next week, we will continue, but then we will start exploring the no-code platforms. So next week, we will do the same RAG, but with LangFlow. So IBM owned this data stacks company, which has this no-code platform called LangFlow, where it's like a UI based. You can drag and drop all of these components, what you see here, and uh, build a pipeline like the RAG. So, and then we'll also try to explore one of the hyperscalers, most likely AWS Bedrock. We'll explore AWS Bedrock also, next week, and then build RAG, build knowledge source, and build a RAG next week. Okay.
Arun,
So
I
that,
have a couple of questions. Can I
yeah,
ask now?
yeah,
Right.
sure.
One thing about the chunking, I was reviewing the notes. Um, so, for a simplistic, application, the chunking is something that or any developer could do it, right? But
Mm.
when it is like large amount of data, right? At that level, how do you effectively do this chunking? Because is it like iterative back and forth, or are there any guidelines about how you should do it? Because it cannot be arbitrary, right? That you put some number and then do it.
Yeah, so ideal, see, there are some, it's just like we were talking about the other day, the prompt engineering, right? Remember, we
Mhm.
had some prompt techniques. So there are some frameworks. It's similar in the case of chunking as well. There is no hard and fast rule. It's just, there are just some guidelines. I can check. So there are some, what you call the articles of how you can experiment with different chunking size. The most see it again depends from use case to use case, as you said, right? So if it has a smaller data, that's fine. If it is a big data, if it's huge uh, documents, it is going to be an issue. But most likely, the chunking size should be around 1,000 tokens, is what is generally recommended. 1,000 words per chunk is what is recommended. Again, it
Okay.
depends on how many tab. Let me, so I can send you some documentation I have. Uh, Last time, in the last batch also, we talked about it, the same chunking. And then, Yeah, so there is this article where it talks about some of the frameworks. One second.
Are you sharing
I
anything?
could see only logos. Yeah, we couldn't see your screen.
Okay, yeah. Um, so there is this article on 21 chunking strategies for that. Again, as I said, right? So we had the framework for the for our prompt engineering, right? The same thing here. It's not a uh, industry standard. It's just some of the strategies practitioners have come up with. So basically, tweaking chunks, switching embedding models, swapping out retrievers, fine tuning rankers, rewriting prompts. So first we said, right, naive chunking split by new line. Each line is a new, each line is a chunk. So this is the most popular or mostly used technique in the RDBMS because each record is unique, right? So when you do in the, for example, person data, relational data, so each record is unique. So it most likely be one chunk for each record, right? Because you cannot add two different records unless what we have done, one of the use case we done for the master data management for deduplication and ranking the customers to see who are most likely living in the same area or living in the same household based on having same last name or same address kind of a thing. So what we did for a chunk was we kind of brought in all the relational data, person, address, products, membership, everything, and concatenated together with some what you call the feeders or injections. Like we formed a meaningful story out of all of those information from different tables. For example, hey, this customer Harun Syed, first name plus last name Harun Syed, lives in, and then we put the address. He lives at Selena, Texas, and then he has been our customer from whatever, calculate the years, this number of years, and he had this portfolio of these are the products that he has bought from us, and he's if he had any issues earlier, so he was having concerns with this products, and then what we have done with. So we build take all of the information like 360 from a customer, and then we prepared a meaningful story out of it, and that became our one chunk for the embedding. So when the customer asks the question, it hits the right chunk, right? Or when we're doing ranking, it does based on all of the related information, the embeddings, right? So if they have the same address, say for example, my son or my wife had another record, so because our address is same, the distance between these two embeddings would be small. So that would come up as a possible closest match to my record, though the first name is different. Since the last name is same and then we are living at the same household, we get a much higher ranking of associated record than other records. So that was one chunking strategy we use. So it's all like, again, business use cases, right? You can say fixed size, right? This is what is said by word or character count. But then, as we said, even if it cuts through the sentence, so it can break in the middle of a sentence, middle of a paragraph, that's when you have to do your overlap, so that the first paragraph where is cut, in the second paragraph or in the second chunk, you repeat the last 20 or 100 words from the first paragraph, so that you get a uh, you get a connectivity, right? So this chunk and this chunk in the embeddings, at least you get some association because it is a continuation from the previous chunk. So then when you use it raw, messy, text dumps, scan documents, transcripts, large text files with no punctuation or headings or structure, then you have a sliding window. It's the same thing, as I said, but each chunk overlaps with one before. So you have a lot of these, some of these as guidelines, right? So it's again your solution architect business use case based on this, which one suits better.
Okay.
Okay.
Mhm.
Uh,
I mean,
Paragraph
why,
English.
why? I mean, I'm just thinking loud. That why is this chunking important then, right? Because it's ultimately taking all the data and then doing the embedding.
Mhm.
And if it is at the end about tokens, right? Ultimately, I have to divide into 1,000 tokens or
Yeah.
whatever, right? So why not do it in one shot, or why not break into a big, chunk of like five? I mean, how this chunking helps?
Two things, right? First, if you don't do chunking is, see, just you are splitting the entire data into smaller parts. That's it, right? So let's say if you don't do chunking, you have massive documents, a 100-page document. Okay. And
Mhm.
then you have several such documents. So if I ask a question, since your entire document is one chunk, okay, or one embedding, so every time you ask any question about a, suppose you have digitized the textbooks, English, math, physics, right? Anytime I ask a question about English, you are going to send the entire English textbook to the LLM because you have not split it, you have not put it by chapters, you just embedded the entire textbook, for example. I mean, again, there is a limitation of embeddings, right? So this is one reason. Okay, for example, just forget about it. The first reason is you are going to throw the entire text every time into LLM. So look at how many, as you said, tokens that you are sending to LLM to process. First thing, right? Second, the focus is very blurred. If you send the entire textbook and ask one question, the LLM has a lot more to process and give you the answer. So the answer is not very laser sharp because it's trying to consolidate answer from so much of the text, right? So it may not be very perfect or very um, what you say, close to what you are looking for facts, because wherever that finds the similar words in the entire textbook, it's going to get all of that information and try to summarize for you. Okay. The second one is the context window or the embedding window itself, right? So we know each embedding model has a limitation that it can only embed this. We checked in the last uh, when we are doing the embedding models. So each embedding model has a limitation of the number of tokens it can embed in one shot. So about 10,000 or whatever, I think 100K or whatever. So that is again a limitation. You cannot go beyond that, right? And the third and the third restriction, or you can call guidance on that. Why is this? Because related related records, right? So if you ask a question, you are trying to filter the data before we send it to the LLM. Again, it might say you are not rate limit, or you might say helping the LLM to be more focused on what you are asking. So if I ask about, for example, projects, I'm only going to send the data related to projects to the LLM rather than sending the entire resume or entire textbook every time to the LLM. So these are some of the things that, and then there might be re-ranking, uh, right? And then there will be semantic search things. So there are a lot of things that you need to do chunking because otherwise it will all become into one. So if you have 5 products and you put all into one chunk, then you cannot do a relative ranking between those products unless they are in different chunks, and then you find the relativity between those products or those customers. If all 5 customers are in the same chunk, what are you comparing that with, right? So things like that. So there are a lot of benefits
Okay.
and limitations also, where you need a chunking strategy when you're doing the RAG. It's basically like, giving it a structure for the unstructured, like in RDBMS also, you don't write all the records in one line, right? So you split it by ID. Each entity is different. But here you're more or less doing by the length of the text than the meaning. Because anyway, when you do the search, you would only get the relative results based on the embeddings. Okay, but these are, yeah, so different strategies based on use cases. So if you have a JSON file, like log entries, so how do you do chunking? So you do chunking based on the each text based, the tags, right? Markdown elements that you structured chunking kind of a thing. Document based. Some you have headers for each. In the PDF document, you have header sections. So you can do a chunking by section wise. That is one strategy. Keyword based. So I have here, you can go through. I'll give this. I think we discussed this in our last batch also. I'll send you this link. You can go through it. But again, as I said, these are all guidelines. There's no industry standard that you should do this way. But this will just help based on different source data that you are coming across. What is the best strategy to apply? Again, it gives you a good starting point. Right? So instead of doing the same chunking like 1,000 words for every type of source, you can at least say, hey, based on the type of the files, like text or structured document or having headings or a JSON file, log files. So the structure, you can you can apply different chunking strategy. Okay. Does that help? See here, table aware,
Absolutely. Yeah.
separately, table aware, basically. Documents, if in a, so you have even in the PDF documents also, you will find tables, or if it is a CSV file, something like that, tabular data, what you want to do, content aware chunking, contextual chunking, the recursive, semantic, embedding, agentic, hierarchical, modality aware. Okay. Yeah, I'll give you this resource. Probably I'll put it in our chat group. You can give it a reading. It should be a good reading for you guys. Probably from next one I'll add it to our deck. The next session. Okay, so let's come back here. So, okay. So we talked about this, like from day one we were talking about all of these items, and then we started adding each of the components into the overall pipeline, and then we built the entire RAG architecture. So this is, as I said, this is all that happens, building a chatbot, except that you need to maybe have a API for this to integrate all of this as an application. So once you build this as an application, all you need is two components. The first one is, let me see. Let's say we have a chatbot, chat application, right? Chat GPT. And then we have this RAG application we have built. What else do we need to make this RAG as a chatbot? if you want to just package it as an application, right? So as a chat bot, and say you give it to the want to give it to the customer, they now the can go here and ask your questions. So what else do you need to do on top of this RAG architecture?
In the system command, we can prompt like act like a chatbot.
System call?
The system and human, you pass the parameter, right? So in the system, you can define like
Okay.
a act like
That's
a
all.
chatbot.
Everything is done. Okay. So everything is done here. All this, your core application is ready. Now, how do you interact with the user? How do you interact with this application? So Pinecone
Maybe
wait, yeah, Vinay.
maybe we need to have any front end to interact.
Exactly. Yes, you're right. So yeah, we need to have just like a UI, just like ChatGPT. When you open, you have a ChatGPT when or Anthropic or whatever. You first open a web page, and then you have a text box there where you ask your questions. So that's your UI. Now, and then the UI is on the front end, and then your RAG application is on the back end. The entire engine that runs and gives you. So from the UI, the user gives query, and then the user gets the response there. And in the back end, you have this application that takes the user query and then runs and gives response. What else is missing? How do we connect these two?
Setting the context for each user.
Yeah. Context windows, maintaining the thread, maintaining conversation is all good. So what we do is what's missing here is the API. So you have to build the front end, and then whatever question you ask, you have to call this entire application, right? Endpoint. So you deploy this application onto an endpoint, whatever it is. It can be on any of your hyperscalers on AWS or Azure or endpoint or AWS endpoint, wherever, right? So, or fast API, deploy it to an endpoint, and then just call that endpoint from your UI. So once the user asks a question, take that question and then call this endpoint with that question. So that API will go and call this RAG, run it, take the response, and come back and put it on the user. So that's your complete chatbot. So once you have built this, you need two other things. One is the UI and the other is the API. So once you deploy this, you have an endpoint, okay, as an app service or a web service, whatever. And once you have that endpoint API, you build a UI, whatever, front end, and then invoke this API whenever you have a question. That's all you need. Just need some wrapper on top of this to make it look like a chatbot. But your entire engine is ready in the rack. Understood? Okay, for any of the chatbot applications to build, either customer support, legal, or whatever. So this is your engine. You have all your raw data sources that documents from the customer support. You build the data. You build the knowledge store. That is your vector database. And then in the UI, you build a UI and the API. Deploy this and then give it an API endpoint so that you ask the question and then you can go to it and get answers from any of your knowledge source. So go ahead, build this in the backend. And it's okay if you have just from the notebook. When we come to discussing the deployment, then we will come back here and see how we can deploy this using Fast API. Okay, and then interact with it. But for now, at least you can go ahead and build this complete application as a chatbot engine for different sources. So figure out, get your own use case, get your data sources, and then start building this architecture. Okay. Now I think we will go. Let me. Why is this share going away every time? 1 second. Are you able to see my screen again?
Yeah.
Right. So we'll do one more use case here. But before that, I want to get here what we are doing. Pinecone. Okay. So I have logged into the Pinecone vector database. It's a cloud-based vector database, Pinecone, and created an account with this, and then we created a database. Okay, so in this database, I have 4 indexes. So basically, you can have a collection or you can have a index. It depends on what different databases kind of implemented differently. Some call collections and some call data indexes. So in Pinecone, what we have is indexes here, and then we have API keys. As I said, this is the API key you create when you want to connect from your application. So remember here, I have this Pinecone API key I set up here to access the Pinecone. If you go here, so Pinecone API key is what I'm going to use to connect to the Pinecone. So once I give this key, it automatically connects to this database. Okay, and then it has access to all of these collections. Now, if you see here, you can go ahead and create a new index on this database, which is AI agents. It's the database. Okay, this is the account. So I'm going to I can create a new index, this new collection. Okay, just think of it like in RDBMS different schema. Okay, but here it's more like schema and table together, synonymous. Or you can say this as a database, agents as schema. These are different tables or views, something like that. But it's a complete new separate entity, just like its own schema. And once you create that, there are options how you want to do the settings for this. First thing is, we know that we want to have every index in vector database. We need to do a embedding, right? So it stores embeddings. As I said, we can generate the embeddings in our application using any of the embedding models, right? OpenAI, or we can use Cohere, we can use Anthropic, or Hugging Face, All Mini, LMV6, whatever. Or, as I said, some of these platforms have their own hosted models. This is NVIDIA has hosted on Pinecone. Microsoft hosted model. Pinecone's its own hosted model here to do the embeddings. This is OpenAI's embedding model. This is embedding model, small, large, and small. Okay. So you can define what model you want to use by default. So if you don't specify an embedding model or you don't specify embeddings, you can directly call this vector database to push your chunks. So it will use the hosted model to generate the embeddings before it writes your data into the vector database. So you have an option to choose any of these models. Okay. Now, even if you have chosen this, you can still choose to use your own model to generate embeddings and put your data into this. So it's like default. Whenever you write any method, right? So you give some default method, default value to some variable. But if you pass a variable a value, it will be overwritten. Or if you don't pass anything, the default value will be used, right? The same thing here. If you don't give any model or to generate embeddings, it will use what is the default model that you have chosen here. Okay, let's say I'm using text embedding 3 small. Now, index is configured, modality is text, vector type dense. See here, Neeraj, max input is only 8,000 tokens for this. So you cannot,
Okay.
you
Mhm.
cannot go and put all your 1 GB document into one chunk to embed. So there is a limitation. So you can't go beyond 8,000 tokens. See, obviously it has to make sense, right? It has to generate a vector based on 1500, 500, whatever dimensionality, so that when it is comparing with other things, it has to make sense. So the more data you dump, the more complicated for it to generate embeddings, meaningful embeddings, context-aware embeddings for it. So that is why they have this models have the limitation. So dimensionality again, you see 512. As I said, some of the models will give you an option to choose which dimension you want. You can go 512 or you can choose 1536. Again, but when you choose this, once you fix this, it's done. You cannot change it again later on the index. You have to rebuild and redo all the index and all the data. Okay, it's 512. I have said I have used it. Then tomorrow I cannot come and change it to 1536 and continue use it. It will not allow. First thing. Second, if you are doing 512 here, and you say from application you are sending data embeddings which have 1536 dimensions, it will error out. It will not save. So it has to match what dimension you have your index, your data you're sending in should also match with the dimension. It's just like, in the RDBMS also, if you have a integer, you cannot put text into that, right? Or if you have a decimal place, for example, it allows only two decimals, and you're trying to put 5 decimals. So it'll error out, or it'll truncate. But sometimes, here it will error out. It will not truncate, but it'll error out. And then there is a metric which it uses. We talked about this, right? The 4 different techniques, metrics that, to calculate the distances. So this uses the cosine similarity search. So we had cosine similarity, we had dot matrix, the dot product, we have Manhattan distance for 4 techniques, metrics that we discussed. So this model uses cosine similarity here to do the search. Now, if we change this, so to go to Pinecone thing, see here, you can only input 512 tokens. Okay, and the metric is dot product. So this limitation, this is one of the limitation that also dictates your chunking strategy. And this is your metric is your dot product if you want to choose. So multilingual Microsoft E5 large, again only 500 tokens. Starter limits, I don't know, it's 5 million tokens. I think it's total to our limits. So dimension is 1024 and metric is again cosine. Starter limits, you mean, so this is the one, starter plan. It's basically, it's giving you for free, I think. Yeah, for free, you can do 5 million tokens on this plan. This is from NVIDIA. So Llama text embed v2. So what NVIDIA has done is it's taken the Llama open source model and then added it on its own to generate a text embedding model using this. The token size is 2000 tokens minimum. Again, starter limits 5 million tokens, dimensions 1024 and cosine similarity search. Yeah, Vinay, tell me.
Harun, so here we have input, right? Max number of tokens that it can actually allow. So based on like let's say 500 tokens, 512,000 tokens. So based on the max input tokens, can we assume how much data we can, like how much GB of data we can feed it, like based on the tokens?
No, you can choose to feed in any amount of data. It's only that
Okay.
each chunk, when you are chunking, each chunk should be 2000 tokens.
Okay. So when
Okay,
embedding,
so
we
if you
need to
have,
make sure.
yeah, if you have, say, for example, 1 GB, which is, 10 pages of data, and each page has 1000 words, right? So 10 pages is 10,000. So when you put a document of 10,000 words, you have to split it by at least say maximum, let's say you put 2000. So your document will be split into 5 chunks. You cannot split it by, make the entire 10-page document as 2 chunks. So then it will be, say, 5,000 tokens per chunk. Then it will fail. So if you put a chunk size of 2000, it doesn't matter how much data you have, 1 GB, 10 GB, 100 GB. That is just storage. But that will dictate how many chunks you will get, how many records you will get in the database.
Yeah.
Okay.
Thank you.
Instead of 2000, if you put 1000, then for 10,000 document, you will have 10 records. If you put 2000, you will have 5 records in the vector database.
Oh, okay. Okay. Got it.
Okay.
Thank you.
But the total record, the total size of the source data or total size is not limited. It depends on how much you have scaling capacity, your storage, your pricing. It's just like how much data you can, you want to put it in the vector database. There's no limitation on that. Because this is free, a starter plan for up to 5 million tokens you can do. So there is once you do choose this model for your configuration, then there is a capacity mode. Okay, just charging, as you said, right? So once you create, it will be charged. You have to pay for this storage and embedding, processing and writing and managing the embeddings, right? So that is serverless. It will automatically charge the Pinecone will charge you, just like any hyperscaler, Azure or AWS. So the underlying platform, cloud, on which cloud you want to deploy this. Again, Neeraj, I don't know if Deepak is here. So we talk about security and all of that, right? So it's just kind of, let's say you are doing a MongoDB, right? So MongoDB is again on the cloud. So which cloud you want to deploy your MongoDB or their own cloud, and then you connect to it and get data and put data using APIs, secured authentication and APIs. The same thing here, Pinecone has its cloud, but your instance, you can choose to deploy on any of these cloud providers. If your organization already has AWS, you can just choose, okay, I will use AWS to deploy this Pinecone vector database. I will use it on the AWS cloud or Google or Azure. All your data will be stored in this vector database index on this cloud. So Pinecone will charge you, and then they will pay these for providing storage and processing and all of that. Standard architecture with any cloud hosted applications. So they can be on their own cloud, or it can be on your organization, your company's cloud. You can schedule this and run this. Which region you want to schedule and add this. So these are the different things. Now, your starter plan, basically this is for you guys. If you want to practice, you're on a starter plan, then you can go and see subscription plans. If you're an organization, enterprise plan, so minimum is 500 per month, and then rest depends on your usage. Standard, this is free current. Okay.
So a quick question in here. So for the LLM APIs, right? The
Mhm.
input is free and output is where we pay, right? Most of the time. For
No,
embedding
input is not
model,
free. Input is not free.
input is not free for the LLM models, like for the, I
No,
thought, okay.
no. Both the input tokens and output tokens are charged.
Okay. I thought somehow I misconstrued then. I thought that input is free and output is charged. And I thought in this way, in this one is both. But okay, I got it.
Yeah, OpenAI pricing. Here, any model, they will have an input price and output price. Input is charged at $1.25 per 1 million tokens. So if you send 1 million tokens, you will be charged $1.25. Output is charged at $10 per 1 million tokens. So basically your output is charged more compared to the input. For the same 1 million tokens, this is
Yes.
$1.25. This is $10. So you will have same thing for all of these models. I mean, any model. So if your model API is under the licensing, then if it is a charge, it's charged for both input output. If it is free, then it is free for both. Open source model, then it is free. But then they will have rate limits. Because it is free, you cannot continuously bombard the LLM and their processing power, right? So they will have rate limit. You must have seen, just like in India also, you get 1 GB data or something plans for 1 day. So after 12 o'clock, it again resets. So same thing here, some of the models you must have seen, you have only 2 or 3 trials left until this date, then they reset. After some time, the ChatGPT says you are out of, for this model, you cannot use for the next 1 week or something for free, right? So yeah, if it is a open source model, it's free. But if it is a commercial licensed model, charged pricing, so it is charged both on input and output.
Makes sense. Makes sense. Maybe one more follow-up question, Harun, on this. This output, we said like rate limits and all.
Mhm.
So for the text where we have to do some summarization and stuff like that, this one is very effective, right? Because you can then prompt accordingly and put the rate limit. But if I am on sorry, you're saying something?
No. Go
Okay.
ahead.
But if I'm on a Vive coding platform, right? So I'm trying to generate code over there. There I cannot effectively mention that, hey, summarize this thing in 100 tokens, right?
Yes.
Are the Vibe coding platforms not different in that sense, or are they also following the same, max limit and that?
Every model follows the same. It's just that you will not be able to rate limit that. See, it's again, you are consciously giving access to the your developers to use that for coding. So you should be prepared to bear that cost, because you're not opening up for the customer use, right? External use. It's for the internal employees most of the time for vibe coding. But definitely, yes, your coding also, everything is token. It doesn't matter it is a code or text or I don't know how image works. Generating images works. I have to check that. Now you have asked a good question. But at least for the text and the coding, it's all token based.
Okay. Makes
For the
sense.
images and videos, they have again, some kind of metering is there everywhere. Even for images and videos, they have some credits. So every time you generate an image, you use some part of the credits, no matter how complex or complicated it is. I think for each image it generates or regenerates, every time it generates an image, some credits are used. So some models work with credits, or basically the platform that uses. Say for example, I'm using Midjourney have their own models, but you may not be using charge directly from the model or what the model is doing, but mostly from the Midjourney itself. They do the metering. So every call that goes to any of their model to generate an image, some credits are used. So they do the metering. So you run one prompt, one image is generated, you get 15 credits are cut off from your total. And then once you buy something, you buy credits, not the tokens. So something like that. So every platform has their own metering thing, but at least the coding and text are mostly on the tokens.
Okay. Got it. I was just wondering, right? Because in the
Yeah.
vibe coding platform, you really have to then be very careful because they can also throw a lot of, unoptimized code, right?
Yes,
So
yes,
then
yes.
about
Obviously,
it.
yes.
Okay.
Yeah. Even the models also these days, right? If you use Anthropic, if I just ask a question, it gives me a 10-page answer. Since it is free, I don't worry because I'm not paying it. But once I start paying it, I would worry because I don't want a 10-page document for every question, right? So I would have to
Mhm.
clearly give my instructions or in the system message instructions, how much output I want, how to summarize or give me the top 10 or something like that, summarize in one paragraph, summarize in one page, give me the bullet points only, give me the resource, something like that. So you have to very clearly add those instructions, otherwise it keeps dumping. It keeps running for minutes, generating 10-page, 15-page documents.
Exactly.
Sometimes it is useful, sometimes it's annoying, right? So you have to be very careful for that. Okay, so let's get into this one. Again, another use case. So what we looked at was talking about the Pinecone. Now we have this index we can create.
Arun, sorry to interrupt you in between. No, one minute. So under configuration, if you scroll right completely, so there is manual build or something in the model. Manual configuration. How this will work generally?
So you see, each model has, as I said, the metric, right? So if you want to change this, you can change here.
Okay.
So
So we can choose specific product and change or actually.
yeah, you can change here, but once you create that, then you cannot. So here, if you're creating, you are not selecting a model here. Okay.
Oh, okay.
So you are providing your own model. There is no model here for the manual configuration.
Okay.
So you are bringing in your own model. You can give what dimension your model is. See, the length of the vector, larger dimensions require more storage. So if you are using EDA 002 or you are using Titan Nova embedding model, so you can give that information here to create a vector index which is matching with that. So does your model, so this is okay, you can choose dense, want to store dense, sparse, what metric you want to use to do the search once you store the data. You can select this dimension, what it has to match what your model is generating there and what you are storing here. Okay, these are the things. Bring your own kind of model, right? So where you can configure these things. So if you use one of those, they have their default things here. So you cannot change the metric for this model if you use, because that's already implemented.
Yes.
Okay.
Yes.
So yeah, so I can just go here, take this all default things and then create index. So this index is created. Now this is your host. Wherever you want to connect from external APIs or endpoint, if you want to give to anybody, this is my Pinecone vector index. If you want to search, model is Llama Text Embed V2, serverless, dense region, cloud. So all of these are required to connect to this Pinecone environment. And then once it is ready, you can look at how many calls were made, read and writes to this index. You can check parameters. You can see here, input type, truncation, the record field, text, sample record. You can go and directly upload the data directly here instead of the application. You can directly give your document here and then upload it to do the chunking and all of that, the vector database kind of a thing. Here you can go and add ID and text. Here it will automatically embed it and write that record for you. There should be somewhere. Okay. So once you have created index from here, of course, you can also create it from your application. So these are all the old ones. Here you can choose to delete if you don't want this, or you can choose to say it gives you the boilerplate code how you want to connect to this index. So see here, it gives you the API key. All you need to do, if you use this key, it will automatically connect to this database, and then you can give your index name. What is the index you want to connect to? So simple to connect from the Python. So that's what we are also using here to connect. Okay. Now we have created, we just want to grant access. I'm using OpenAI API key. This is my LLM model 4.0 mini. Right now, based on the index, right? So here, this is the template. So we are talking about, there are 3 different types of messages: system message, human message, AI message. Okay. I am pre-populating the chat information here. So what I'm doing here, I'm saying system message is you are a helpful assistant. Human message, hi AI, how are you today? AI message, I'm just what you call giving a sample data. I'm pre-populating, assuming, okay, this was the conversation already happened with the LLM. So system, I asked the question, the answer, I'm adding it to it. And then there is another human message, the next in the chain. I would like to understand string theory. So all of these go into the prompt when I send it to the model, because I'm sending this messages array with all of 3 different types of messages. So it will understand what is the human thing in this, what is the AI thing in this, and what is the system thing. So based on that, so if I run this, so my model GPT-4o mini, so we are not yet adding the Pinecone here. We are not yet going to embeddings. It's just, I have created to connect to a LLM model, OpenAI, and then chatting with it with different templates. So if I put here, chat, send it, So I will get the response based on this conversation. So this is the conversation. Now we want to do a simple thing here. Let's say, let's see, I'll just put here. Okay. So let's try this. See here. It can answer this. What I did was I gave a system message and then I gave a human message that, hey, this is my name. And now I'm asking the question, what is my name? So it is able to read from this and answer this from the context, from the conversation. Now, if I remove that and run and see here, it says, I don't have access to personal information about user. So it does not know this, what is my name. But here we are building that chat history. Okay. Now, let's say I did this. I'm just trying to, I removed this here. Fine. What I did, I only added, got this. I got a AI message here. I sent this information in the chat to LLM. It said, hello, Harun Syed. How can I assist you today? Great. Now, I go here. I will change the messages. Remember the sequence of what I'm doing. That is more important here. Now, in the messages, I have this. Okay. I will say messages dot append press. What am I doing here? Beautiful. I don't have to do it, will automatically prompt. Okay. Now, anybody who wants to talk about this, what we are trying to do here? Gopi, Neeraj, Vinay.
I think you're appending it to the human message that you had sent earlier, right? So,
Correct. So earlier, my messages have system message and human message. I called the LLM. I sent this. It gave some response, the AI message, which is in the response. So what I'm doing this response, I'm adding this entire response back to the messages as it's already as an AI message. So now my messages object has this system message, this human message, and this AI message. All three. Okay. Now what I'm doing, asking another question, what is my name? So it knows my name here because this messages has now all the information, this one, and this one. Okay. So if
Sayed, we have a human message, also the AI response you're sending back, right? In case if you're giving a different answer for a AI message. So which one is the preference here? It will take a human message or it will take a AI message as a
everything will be
no.
there in the context. It will
No, we
remember.
are giving incorrect. For example, you gave a name as a Sayed, but in the AI response you're giving as a Harun. Okay. So here the next answer should be a Sayed or a Harun. So can you try that?
Or you're saying if I remove this.
Yeah, remove that, and then AI message just pass your name is Harun, something like that.
Yeah.
Next AI message.
No, AI message it will already generate it, right? It's not I am sending something.
No, we are feeding something like that. You manually
Whatever it has got back, we are feeding the same thing.
Yeah.
Whatever is the response.
Instead of you are feeding the same message, you are hard coding some message. Let's see how it behaves.
Yeah, we can do that. So you want to put here this.
Yes.
You're manipulating.
Yes. Remove the last one. Let's see what's the response. What's my name? Like that you can ask.
Your name is Sayed.
It's taking human messages.
Yes.
That's good.
This is only for the context, what earlier the AI has responded with. If you want to ask a follow-up question based on the AI message earlier, then it has all the history to go back and see what the user is referring to. Right?
Good.
So if I don't give this, if I have not given my name, of course, the AI message will not be there. But if I just want to, let's say, replace this, okay? This is the chat history. So in that, I'm taking out this part. Okay? And I'm saying this is the AI message. And then I'm asking the question. So it will refer back to the content. It should refer back to the content and see now your name is Harun. So it goes back to look at the context. If it has already answered anything in the answers or if the user has provided. It looks at both to come up with an answer. Since now from this chain, I have removed what I have given input, but still retained that what it has responded earlier as a context, it looked into its own context to answer that. The moment I remove this also, then it does not have anything to refer to. Then it says I cannot answer with the personal information. Correct? Now, you can say, hey, how can I keep sending all of this every time, adding it, input, output, messages, everything, it keeps on increasing. You're just appending everything. So for that, you use the buffer memory, conversational buffer memory, where it keeps adding all your conversation to that memory and it refers from there so that you don't have to maintain this. This is to show you how that conversation is maintained for the context purpose. Okay. All right. So this is, I don't know, when you look back at the recording and want to practice this, you might get confused, but follow the recording, what we are trying to achieve here. So I will just make sure that this code snippet is there so that you can see what is the response from each of this. Okay, just check and go through this. the same thing here, so we don't need to run this. If you have the human message, what is my name and all of that, it remembers from the conversation. So now what we are trying to do here is from the messages, I'm asking a question about DeepSeek R1, which is a new LLM model. I mean, at that point of time, so there might be more latest DeepSeek models. But when that model was released, what I'm using, it may or may not have the context. So as I said, right, the LLM has cutoff date. DeepSeek R1 came much later after the model's cutoff date. So I'm adding this prompt to that same messages chain, and I'm running this question to see what answer the model gives me, LLM model. Okay, so it says as of my last knowledge update in October 2023 is not been specifically mentioned anywhere in the available literature or media. So it has not been trained on that. So it does not have any context or me understanding of what this is. It does not know. However, since you said LLM model, I can talk something about LLM model in general, in generic thing, not related to the DeepSeek R1, in general about LLM model. So what I'm trying to do now is I'm trying to induce that context. I'm giving that source knowledge. Remember, how do we do this in our RAG architecture?
Embedding and then passing that output to the
So we normally put it in the embedding and vector database and retrieve the results and then send it to LLM. The same thing I'm hard coding here. Hey, this is the source knowledge for you about DeepSeek R1. So what I did, I have this conversation chain messages. Okay. But now I've come out of that messages. I'm creating a new query and an augmented prompt saying that using the context below, answer the query. Context is this source knowledge. Query is this query. So I'm passing this as a human message, and to the messages, I'm adding this prompt. Human message. The content is this augmented prompt. So in the augmented prompt, again, I have a context and I have a query where I'm replacing with this string context and this question to the same conversation chain. Now, once I add that to the messages, add this prompt, again, I will ask the same question. What is special about DeepSeek R1? So now it says DeepSeek R1 is special for several reasons: enhanced reasoning performance, comparison to continuous, all of this. Since, see, the model itself does not have any knowledge about it, but it's giving this answer based on what we provided it, this information about the source knowledge, since we are passing it in there. So it's sending all of this. So specifically OpenAI 1217, it is getting from, see this here, OpenAI 011217. So it read and referring to that information and providing you the answer. Okay. Just try to just so that is how building the conversation chain, talking to LLM manually looks like. So what I'm doing here again is I'm taking a data set from data sets, import that load data set. This is online. There is a paper called DeepSeek R1 paper. It is already chunked. They have already created chunks. You can go and look at this in the load data set where there's this paper you can see. For the machine learning purposes, this paper is already chunked in the Hugging Face. So this is the paper, James Callum DeepSeek R1 paper chunked. So these are all the chunks that it has. Okay, it's already 76 records, it has chunked. So you can read this in the data set. Number of rows, 76. Okay. If you see, each chunk has a chunk ID and some DOI, and then the actual text here, page, and the source. The source is original source is the arxiv.org, where you have all the research related papers stored online, arxiv.org. So this is the source data that we are taking, and then now we are going to Pinecone. Okay, so index name is this. Now I will just drag V2. I can go and say cohort 5 index. This is the new index that I am creating. If not, PC has index. It's checking if it has already index or it does not have index. Then we are creating an index in the Pinecone. Name is this index name. Remember all these features? That's why I have first shown you. We got to Pinecone and seen how all of these parameters are used. So metric, we are using dot product for this. Dimensions 1536 because you're using text embedding 3 small. Serverless, we are using on AWS, US East 1. Okay, so this is the index. Now we run this. Error. Invalid argument. Name must consist of lowercase alphanumeric characters. Okay, fine. Will not use capitals if you don't like it. No. Oh, you have reached max serverless indexes allowed in project AI agents. Okay, so because we are using the old things. Let me go here. We just created something here, so we will delete cohort 5 because we can only use maximum, I think, 5 indexes on the trial. This is terminated. Now let's go back and run this.
So I think index is like a schema.
Sorry, come again?
Index is like a schema in the database.
Yeah, you can call it schema, you can call it collection. It's one logical entity, you can say. So within the same database, you can have multiple indexes, each index with a different configuration. Okay, so one index can be using embedding 3, one index can be using ADA 002, one can be using dot product, one can be using cosine. So each index has its own configuration. So within the database, you can have multiple indexes with different configurations. Okay. Yeah, now this is created. You can go back and check. Where is it? Refresh. Yeah, see here, DeepSeek R1 RAG cohort 5 is created with all of our dimensions, whatever we have given everything. Now Again, so we said we are using text embedding 3 small for embeddings. So if you see here, in the configuration, it just says, so metric is dot product, dimensions is 1536. So record count is 0 here. Okay. So this is a lot of boilerplate code here. Don't worry about it. We are not here to learn Python coding. All this is doing is reading the data set, splitting the batches of 100, and then this 100 is not your chunk size. Okay, so don't confuse with it. It is already chunked. The document itself is already chunked. So we are taking as is based on the chunk, start of the chunk, end of the chunk. We are taking that. And then we are in index.upsert, our index, vectors of ID, embedding, and metadata. Okay, so we are doing embed documents for this text. This is our embedding model. Embed model is our text embedding 3 small, embedding text. So this text is for each chunk we are getting into a collection or a list, and then passing that to generate embeddings. Now, once we have that, we are storing in the index what we are storing: the ID, the embedding, and the metadata. Okay. Metadata, again, you have the text and the source in the metadata. So once we run this, it should start adding the documents into the chunks into the index. So if we go here, let's say back to indexes, part 5. See now the record count 76. Is that matching with what we looked at the document? Yes? No?
Yes, sir. Yeah.
Right? So we got exactly, we chunked it based on the already existing chunk size. We took as is the chunks, generated embeddings, and then we have written the data here. So now you can actually see that data in the cohort 5 index. This is the ID, the source, this is the text, and the embedding will be somewhere. Now, taking this as the source, how it is related to other chunks within the document is the score. 0.55, 0.52, 52, and all of that. So if I pass something about this chunk, these are the closer ones that have the score. So now we have put in all 76. We can do a describe index statistics, dimensions, dot product, count is 76 records, vector type is dense. Now here, what I'm doing, I'm getting again the same vector retriever, and then trying to ask questions. What is special about DeepSeek R1? Now this answer is coming from the vector store. So it has thrown, because I want 3 results. So it gave me this ID, and this ID. Three documents, 3 chunks. It has given the results which is related to this question. Now, if I ask some irrelevant question to the same, it does not have anything, but since you asked one, return one, it will just throw some irrelevant information at you, since because you asked it. Okay. That is not relevant to us. You will look at the score, and then you can look at what is the confidentiality score, and then filter it like we did last time, once we get that. Now we have the prompt using the context below. You can add the context from basically the RAG, and then answer the questions. You're sending it to the RAG now. Why is this query here? It's still you don't get. the response. I think we changed it. So the provided context do not contain any information about the recipe for the biryani. Okay. Even if you have all the chunks, even if your retrieved results, it thrown you something, because you asked for one result, even if it is not relevant, whatever is relevant, whatever is the closest, the first thing it comes up, it will give you. Now, but when you take this and give it to the model, it will go through this and understand, hey, this question and the result, the data that you are passing me are totally irrelevant. So I cannot answer this from this context. Now you understand why we need another LLM on top of the vector results, because if you ask for number of results, it will give you the closest ones. It doesn't matter whether it is relevant or not. Okay, it might be very relevant up to 0.99, something like that, or it might be not relevant at all, 0.0001. But the fact that it exists in the vector store and the fact that it is the closest one for the question, it will anyway throw it at you. If you ask 3, it will give you 3. They may not be relevant or exactly relevant, but that's what it has, that it can figure out the closest one to this. Absolutely nonsense. But then you add an LLM, pass this to an LLM. Hey, this is what I have context and this is the question. Can you figure out? Then says, no, your context and question are completely irrelevant. See here, information about recipes does not contain any information. However, I still have my general knowledge. I know how to make it, the recipe for that. I can give you from my own knowledge if you want. But whatever you passed me as results does not have anything to it. See how beautiful, the context it's resolving. It says whatever the results that you have sent me, it's completely opposite what we are trying to do. We are trying to help the LLM with the context, but here the context itself is relevant. Then it's saying, do you want me to answer from my own knowledge? Okay. If you want, this is where you append, right? So let's say there was a question earlier. Can we ask LLM to answer on its own, or can we ask from its context? So this is the scenario where when your context does not provide, then what do you want to do? You want the LLM to answer. Now it's asking question. How do you tell the LLM to answer from its own knowledge here? In this scenario. Yes, Gopi.
Yeah, if we feed incorrect information like 1 plus 1 equal to 3, will it correct us or will it say 1 plus 1 equal to 3 as a response from LLM?
No. Okay. You are asking me another question. I am asking a question. First, let's get this answer first, then I'll answer a question. So in this scenario, how will you tell the LLM to answer from its knowledge, the answer to this question? Because it cannot find the context here.
Maybe in the prompt itself, we can see if the answer is not found response from your knowledge.
Yeah. So where do you add that?
In the query itself.
Yeah, in the query where?
You will
Query is
human
this.
message.
Query is this.
AI message?
Yeah.
No. So the AI message is
No.
the context. So this is the place for you to add it to your system prompt. The system prompt is the overall instructions to the LLM that goes, right? So where is my system prompt? Do I have a system prompt?
So in the human query, it won't understand it and won't respond based on the human query?
Yeah, it can be. But human query might change every time, right? System prompt is like header instructions. It's like you are in the every API, you send header information, authentication information, metadata, right? So it's like that. So it gets appended to every human message question. Okay, so let me say here, system message in the content, I can put here if the answer is not the context, provide answer from your own knowledge. Okay, I'm just giving it a try. Let's see how it behaves. If I add this messages dot append system message. Okay, now let's rerun this. See, the context provided do not contain any information about the recipe. However, I can provide you with the basic recipe from my own knowledge. Now it went ahead. It's not asking you the question. Since you have already given it in the system message instructions, if it is the context is not found, you fall back on your own knowledge. So we gave a fallback mechanism in the system message. So what it did, now it said it's not there in your context. So because in the system instructions, we have approved it to or asked it to go ahead and fall back on its own knowledge. Now it's giving the response from its own knowledge. Okay. Then now we can enjoy our homemade biryani. Getting it?
Yeah.
Great. Okay. So the rest of this document, yeah. So we are anyways towards the end. Basically, it's all the same. Okay. Yeah, I think with that we can wrap up. I got, I think, very, very good handle, very good understanding of how the RAG works, how we communicate with the LLM, how we give the prompts, system prompt, human prompt, how do we provide context, how do we add a vector database, how do we add our indexes, embedding models, right? Very clear understanding foundation. So I strongly recommend you guys to do hands-on. I will also upload this recording and notebook as soon as possible today. Strongly recommend go ahead to practice. Okay, so this we are wrapping up the LangChain part, okay, or the coding part. So next week we are going into the no-code platforms. As I said, we'll explore Langflow, we'll explore Amazon Bedrock next week. With that, we will be completing half of our trainings. So where we will complete the wrap of the our RAG, building RAG. So all foundation and RAG. The week after that, the second half, we will go and get into agents. Okay. So that's the plan. That's how we're progressing. Do let me know if you guys have any questions, concerns, feedback, right? So we will continue exploring. All right. Anything else before we wrap up? Feeling good?
Yes, thank you.
Awesome. Awesome, guys. Thank you so much. If you don't have any questions, we'll wrap up. Take care. Have rest of the day, weekend, whatever, and we'll meet next week.
Yeah. Thanks, Sai.
Bye-bye.
Thank you.